You ever drop something and wonder why it falls down? Well, in this video I'm going to explain that. I'm going to talk about free fall, projectile motion, and uniform circular motion. These topics are important to learn because so many things in this world are impacted by free fall, projectile motion, gravity, uniform circular motion, etc. But I'm getting ahead of myself. First off, let's talk about why something like this ball falls down. It falls down because of gravity. Gravity is the fundamental force of attraction between two objects of mass where they get drawn to each other. The action of the motion of a body like this ball where gravity is the only force acting on it is called free fall. Free fall can be upward or downward. Now when I allow this ball to drop downward in free fall, its velocity will increase as it gets closer to the ground. Velocity is just a measurement of speed in a specific direction. This velocity is accelerating at a constant rate because of gravity. I can assume you're watching this on Earth, where gravity is 9.8 meters per second squared. This means that each second, the ball's velocity is increasing 9.8 meters per second. The formula to find the velocity when the ball hits the ground, the impact velocity, is Vimp equals g times t fall. So if the time that it has been falling is 10 seconds, then you multiply that by 9.8 meters per second squared, and you get 98 meters per second as the impact velocity. If I wanted to find the distance it traveled, I would use d equals 1/2 times gt squared. So with this example, I would square the time as it was falling, multiply it by 9.8 meters per second squared, and then half the total, and I would get 490 meters. Let's say I didn't know the time. I only knew the height of the building. I would use this formula. T equals the square root of 2h over g. So if my height was 50 meters, I would multiply that by 2, divide by 9.8 meters per second squared, and then find the square root, and I would get about 3.2 seconds. Do you notice something about these formulas? Mass has nothing to do with them. When objects fall in an air vacuum where there is no air resistance, gravity accelerates the objects equally. Take a look at these graphs for position, velocity, and acceleration over time. This first graph shows position over time, showing that the ball is falling down over time. But what you can see is that it is decreasing at an increasing rate, meaning that as the ball falls down, the speed is increasing. Take a look at a velocity over time graph. If we assume that positive velocity is pointed up and the ball is falling down, then it would be in negative velocity. Because this graph is linear, it shows that the ball's velocity is increasing at a constant rate of change. If we look at an acceleration over time graph, we see that the acceleration remains at a constant line of negative 9.8 meters per second squared, gravity. Now what if I'm tossing the ball upward? When I'm tossing the ball upward, I'm pushing it into the air with my own velocity coming from my hand. At a certain point, the ball will reach a maximum height and then drop back into my hand. This is because gravity is acting against the ball's velocity as it's going up. Let's take a real-world example, a cannon. Let's say a cannon is pointed straight up at the sky and fires a cannonball at a velocity of 80 meters per second. If we want to find the time it takes to reach its maximum height, we would use this, v equals VO minus g times t. So if we say that 0 equals 80 meters per second minus 9.8 meters per second squared times t, we can just solve for t, where we divide negative 80 meters per second by negative 9.8 meters per second squared, which would equal t, which we get 8.16 seconds. But what about the maximum height? We would use this super long formula. Y equals YO plus VOYT minus 1/2 GT squared. This would mean the height max equals 80 meters per second times the seconds it took to reach the maximum height minus 1/2 times 9.8 meters per second squared times the time it took to reach the maximum height squared. We would get 652.8 minus 1/2 9.8 meters per second squared times 66.59, which would equal 652.8 minus 326.3, which would then equal 326.5. And just as I mentioned previously, when an object falls, like a cannonball, gravity accelerates the object each second it is in the air. The inverse happens when a ball is tossed up in the air. Gravity decelerates the object's initial velocity at the same rate as the ball would if it was dropped. So if you fired your cannon in the air at an angle and then caught it somehow at the same height you shot it, it would rise and fall at the same rate, in the same amount of time if air resistance was negligible. Its path would then be a parabola. And if you find the midpoint, both sides would be symmetrical. Now what if you launched an object horizontally? This would be called horizontal projectile motion, where an object moving through the air is influenced by gravity, if air resistance is ignored. Previously, we only considered height on the vertical axis, but now we're also considering distance, or the range, on a horizontal axis. So let's say that a very daring individual is going to run at a constant speed of 3 meters per second off a 50-meter building. First, we calculate the time it would take for them to hit the ground. T equals the square root of TH over G. T equals the square root of 2 times 50 meters over 9.8 meters per second squared. 100 meters divided by 9.8 meters per second squared. The square root of 10.2 squared would then equal 3.19 seconds. Then we can find the vertical impact speed. Vertical impact speed equals gravity times the time to fall. 9.8 meters per second squared times 3.19 equals 31.3 meters per second. While that seems like a lot, the individual was perfectly fine. I can tell you that. They didn't get squished or anything like that. They survived the fall, no scratches, and no nothing. They're completely fine. And then we can determine the range traveled. Range equals Vx times time to fall, which would then equal 3 meters per second times 3.19 seconds, which would equal 9.57 meters. Do you notice that the time to hit the ground and the vertical impact speed did not require the running speed of the individual? That's because objects fall at the same rate of 9.8 meters per second squared on Earth. If air resistance is removed and you launched an object horizontally and dropped an object at the same height, they would fall at the same time. Now let's switch gears a little bit. Let's talk about force. When you push a box on the ground, you are applying force for the box to move. Makes sense. But what if you're driving in a circular route? Or you're spinning in a circle? Or you're in a Ferris wheel? Well, this is called uniform circular motion. It is when an object moves in a circular route at a constant speed. You see, velocity remains in front of the object as it moves, but it is not constant because of the object's direction continuously changing. The force involved is called centripetal force. This type of force is acted on an object, yet it's directed towards the center of the circle. The acceleration of the object is also directed towards the center, but it is perpendicular to the direction of the velocity. So when the object is at the 9 o'clock point, its velocity is up, and its centripetal force and acceleration is towards the center of the circle. When the object is at the 12 o'clock position, its velocity is pointed towards the right, and its force and acceleration are once again pointed towards the center. A real-life example of uniform circular motion is a Ferris wheel. Let's use a free body diagram to describe uniform circular motion on a Ferris wheel. The force of gravity is always pointed down, and the normal force is always pointed up. When a person is at the highest point of a Ferris wheel, the normal force is larger than the normal force at the lowest point. This is because it has to push more to counteract gravity. At the highest point, the centripetal acceleration is pointed down, and at the lowest point, it's pointed up, at the center. There's also a formula to find the centripetal force, and it is centripetal force equals mass times velocity squared divided by the radius of the circle. So in this video, I described upward and downward freefall motion, horizontal motion, and uniform circular motion, while also providing examples and formulas to solve problems with. Free fall is important to learn because it shows up all around us, in skydiving, sports, fruit falling off trees, etc. Same with horizontal motion, with Earth's revolution, objects rolling off tables, and a bullet fired from a gun. You can see uniform circular motion with Ferris wheels, cars in a circular track, and satellites orbiting around Earth. I hope this video helped you understand, and thank you for watching.